Hello everyone. Now we are starting the next chapter of Unit 3, that is wireless LAN. So wireless LAN, the wireless LAN are becoming more and more popular because they can satisfy the requirement like mobility, relocation of user, ad hoc networking and coverage of location which are difficult to wire. Earlier the wireless LAN were costly. They could support only low data rate and license was required to build and operate them. Hence, there were limitations on the practical utility of wireless LAN. But all these problems are being addressed now and which increase the popularity of wireless LAN day by day. Devices such as workstation, laptop, computer, cordless telephone, and other communication appliances share the wireless medium, such as 5 GHz radio link or infrared links. There are some wireless LAN requirements or properties of wireless LAN. First is throughput. The throughput capacity of wireless LAN should be as high as possible. This is the possible if medium access control protocol is made as efficient as possible. Second is number of nodes. Generally, a few hundred nodes are needed to be supported using the wireless LAN. Next is connection to the backbone. A wireless LAN is the most of the situation it is interconnected with the wired backbone LAN. The ad hoc LAN and the mobile user should also be connected to the backbone LAN. Next is service area. A wireless LAN has the typical coverage are ranging from 100 to 300 meter. Next is longer battery life. The mobile user use the battery power. In order to have a longer battery life, it is necessary to minimize the battery power consumption. Next is robustness and security. Wireless LAN can be prone to interface, so it should be properly designed to ensure the reliable transmission even in the noisy atmosphere. Also, a minimum level of security should be provided from eavesdropping. Next is license-free operation. For the widespread use of wireless LAN, it is necessary to eliminate the need of license to be build and operate a wireless LAN. Next is collocated network operation. If two or more wireless LAN operates in the same area, the interference between them is the possible. Therefore, result is manufacturers of MAC algorithm and may also unauthorize access to the LAN. Next is roaming facility. A roaming facility should be provided to the mobile station when the mobile station moves from one cell to the another. They should remains the network. And last is dynamic configuration. The MAC address and the network management aspect of the LAN should permit the automatic addition, deletion, and relocation without any problem to other users. There are some applications of wireless LAN, LAN extension, second is cross-building interconnection, and nomadic access, and last is ad hoc network. The wireless LAN technology includes infrared LANs, spread spectrum LANs, and narrowband microwave LANs. There are some design issues for the wireless network. First is bandwidth, security, mobility, reliability, scalability, and ease of use. Wireless network use electromagnetic waves or infrared red light for communication between two or more wireless devices. The data to be transmitted is superimposed on the radio carrier or the modulation of radio waves. So first is mobility. The wireless network accept and serve the mobile users. They provide the access to the internet and contact with the other user without using any wire. Installation of the wireless network is the simple. It eliminates the need of pulling connecting wires. Next is reliability. In wireless system, EM waves, that is electromagnetic waves, are used to carry the information, but these waves undergoes the fading or loss of signal due to the various reasons. This will lead to the reduce of reliability, so some minimum level of reliability should be ensured. Next is scalability. Wireless system can be configured in different types of topology depending on the need of the application. It is possible to change the configuration easily right from the peer to peer, which is suitable for a small network to the large infrastructural network used for the large areas. Next is IEEE 802.11 standards for the WLANs. 802.11 are the IEEE specification for the wireless LAN. It gives the specification for the physical and data link layer. There are two types of services provided by the IEEE 802.11 standard for the wireless LAN. First is basic service set, that is BSS, and next is extended service set, that is ESS. Let's discuss this one by one. First is basic service set. So as per the IEEE 802.11, the BSS has been defined as the basic building block of wireless LAN. A BSS consists of the stationary or moving wireless station and the central base station, which is optional, called as the access point, that is AP. A BSS can be either without AP or with AP, that is shown in the figure. The BSS without AP cannot send data to another BSS, so no data exchange can take place outside the BSS. Hence, it is known as the standalone network or ad hoc architecture. However, all the stations inside the BSS can exchange data amongst themselves. Next is ESS, that is extended service set. An extended service set consists of the multiple BSS with APs. The BSS in these systems are connected to each other via the distributed system or a wired LAN as shown in the figure. The AP are connected to each other while distribution systems are shown. The distribution systems can any type of LAN such as Ethernet. The ESS connect two type of stations. First is mobile station, which can move and change the location, and second is stationary or non-moving stations. Out of these non-moving stations are the APs or access points, which are part of the wired LAN, whereas mobile station are those contained in the BSS, shows in the structure of ESS. The BSS are connected to each other to form a network called as an infrastructure network. In such a network, the station closer to each other can communicate without taking help of access point. But if two stations are located in two different BSS wish to communicate with each other, then they have to do so through the access points. This type of communication is very similar to the cellular communication. The BSS acts as the cell and access point as a base station. As shown in the figure, the mobile station can belong to more than one BSS simultaneously. Types of stations in ESS, there are three types of stations that are defined by IEEE 802.11 depending on their mobility in the wireless LAN. First is no transition, second is BSS transition, and third is ESS transition. So first is no transition mobility. It is defined as the station which is not moving at all, that is stationary station or moving inside the BSS only. Second is BSS transition mobility. A station having BSS transition mobility is one which can move from the one BSS to other BSS but does not move outside the ESS. And last is ESS transition mobility. A station having ESS transition mobility is one which can move from one ESS to any other ESS, but IEEE 802.11 does not guarantee a continuous communication when the station is moving. Next is protocol stack. 802.11 protocol stack. IEEE 802.11 has defined a specification for converting a bit to a signal in the physical layer. One of them is the infrared frequency spectrum, and the other five specifications are in radio frequency range as shown in the partial 802.11 protocol stack figure. The five specification in the radio frequency ranges are: first is FHSS, that is frequency hopping spread spectrum. Next is DSSS, direct sequence spread spectrum. Next is OFDM, that is orthogonal frequency division. HRDSS, that is high rate DSSS, and OFDM. So first is IEEE 802.11 FHSS. The IEEE 802.11 describes a method called FHSS, that is frequency hopping spread spectrum, for conversion of bits into the signal. The frequency band used for this is 2.4 gigahertz ISM band. The principle of FSSS is, in the FSSS, the sender sends one carrier frequency for a short period of time, then the hops to the another carrier frequency and transmit it for the same amount of time. Then it hops again to a new carrier frequency and transmit it for the same duration and so on. In the all three are in such hopping in one cycle shown in the figure. The cycle repeats itself after n hoppings. The bandwidth of FHSS signal is equal to NB hertz, with B is the bandwidth of original signal and being converted to the FHSS signal. The technique for spreading used in the FHSS makes it difficult for the unauthorized person to understand and transmit the data. The frequency of allocation band in FHSS is decided with the mutual agreement between the sender and the receiver. The frequency band by FHSS is 2.4 GHz ISM, that is industrial, scientific and medical. This band is divided into 79 equal sub-bands of 1 megahertz of each. The hopping frequency is selected by pseudo-random number of generator. The modulation technique used is the BFSK, that is binary FSK of two level, or MFSK, which has more than two frequency used. Next is IEEE 802.11 DSSS. IEEE 802.11 has defined DSSS, that is direct sequence spread spectrum technique, in order to convert the bits into the signal. The DSSS also use the same frequency band as that of FHSS, that is 2.4 gigahertz ISM band. ISM is industrial, scientific and medical band. Principle of DSSS is, in DSSS, each bit being sent by the sender is the first converted into the group of bits called as a chip code. The time required to send each chip code should be equal to the time period of the original bit in the order to avoid the buffering. Let n be the represent the number of bits in each chip code. Then the data rate of DSSS would be equal to the n times of data rate of original signal. DSSS, even though similar to the CDMA, it is not a multiple access method. A bit sequence used in DSSS used entire frequency band of 2.4 gigahertz ISM band. DSSS uses the BPSK, that is binary PSK or QPSK, as its modulation technique. Next is IEEE 802.111 OFDM. OFDM stands for the orthogonal frequency division multiplexing. It uses IEEE 802.11 as the signal conversion technique. Principle of OFDM. The basic principle of OFDM is same as the FDM, but the major difference between them is OFDM, all frequency subbands are used by one source at a given time. OFDM uses 5 GHz ISM band for its operation. This band is subdivided into 52 subbands. Out of these 52 subbands, 48 subbands are used for the sending 48 groups of bits at a time, and then remaining 4 subbands are used for the sending and control the information. These subbands can use randomly in order to increase the security of transmitted data. The type of modulation used by OFDM is the BPSK or QAM, that is quadrature amplitude modulation. And last is IEEE 802.11 HRDSSS. HRDSSS is the short form of the high rate speed direct sequence spread spectrum. IEEE 802.11b uses HRDSSS method for the signal generation. It uses frequency band of 2.4 GHz ISM band. HRDSSS is conceptually very similar to that of DSSS technique. The only difference is about the encoding method used. HRDSSS uses a method called a complementary code keying (CCK), which encodes 4 or 8 bit of original data into one CCK symbol. The HRDSSS need to be backward compatible with DSSS. Hence, the HRDSSS defines 4 data rate 1 to 5.5 and 11 Mbps. The 1 and 2 Mbps data rates are allocated for the same type of modulation technique as used for the DSSS, that is BPSK or QPSK. The modulation used for the 5.5 Mbps is BPSK, whereas 11 Mbps data rates are assigned for the QPSK type of modulation. And last is IEEE 802.11G OFDM. It is a new specification using OFDM. The frequency band used is 2.4 GHz ISM with the complex modulation technique used. It is possible to achieve data rate up to 54 Mbps in IEEE 802.11G OFDM. Thank you.